Hello everybody, welcome back to From Rhythm to Algorithm. Don't know what part this is. Been a day since I recorded, had to repair some drywall at my house, selling that. But you know how we do it, we're going to pick back up, discuss anything in mathematics, linguistics, physics, discuss logic, empirical evidence, and draw new conclusions and search for our axiom of sensorality and its natural definition. So we got a bunch of things, a lot of derivation, no super poignant results that I can think of just off the top of my head, but same type of things, just working towards our axiomatic derivation. So the first thing that I wanted to kind of discuss is color coding, sensorality color codes, right? We as human beings, as sentient individuals, we associate certain colors with certain phenomenon and or certain characteristics or certain things. So why do we do that? What kind of fundamental empirical fact can we state that tells us or gives us some sort of insight as to why we associate certain colors with certain things? Just for some examples, right? Green, go; red, wrong; purple, royalty; black, profit; black, closed; blue, boy; pink, girl; orange, caution. So, obviously not an exhaustive list, but point being is that we do so. We make a differentiation. Why do we do that? And what sort of fundamental thing can we say? Because obviously, again, we talked a lot about previously how we've defined vibration logically consistently as a workless cycle, just something that goes through a cycle with no work done. Covered that completely in the last episode. But, light, talking about visible light, the color you see of an object is the light that is reflected back to you, that bounces off an object. Those are the two operative words we use. We discussed that, how we can define those as vibrations. But just what else can we can say something way more poignant about color. What is that? Obviously, it's fundamental because all of the other wavelengths, they'll say they are absorbed. So we can make some sort of logical opposition or contradiction, well, not contradiction, but opposition between absorption and reflection, or absorption and bouncing. Again, just a physical opposite. If the light is not absorbed, it is reflected. If it is not reflected, it is absorbed. Those are the two options you get. But just, again, overall, why do we color code, and what sort of fundamental insight can we draw from that? But are there three primary colors, just in general? Because we have the fundamental stability of two, which we've demonstrated tremendously throughout language. There's a lot of different historical things like yin and yang, good and bad, good and evil, up and down, left and right. The fundamental dichotomy of two. Again, that was the last stabilized evolutionary period or epoch. Again, just a time when the universe had just energy and vibration, and now we have energy, vibration, and momentum, but just frequency, energy, and mass. And so, just what kind of interplay is there? Three primary colors, because you have the logical concept of, a primary color is something that is kind of, in a sense, basic, is foundational. No two colors can be mixed to make a primary color, red, blue, or yellow. And so what kind of fundamental statement or proof can we state from that? Not sure, but certainly something is going on. So why do we color code? Up next, but another thing that any of the astute students of Brad's YouTube channel with 3 views for 10 seconds, but and at this point I'm confident that I've proven paradoxes can't exist, contradiction naturally in language does not exist. But then you might raise your hand and say, hey Mr. Brad, what about lying, right? Clearly you can lie. And so, right, lies are contradictions, but they're not natural, they're not inherent. And so you have to have the intentionality to deceive, to create a lie. So it's not a genuine contradiction. So that's a nuance to the proof, at which I'm sure someone might have pointed that out, but we wanted to be complete here at Brad's Science Camp. But lies are intentionally wrong, and they're not genuine contradictions. And so, contradiction is against diction, literally, contra against diction. But if language was contradictory, you couldn't understand anything I'm saying at all, right? We've proven the consistency of language, but it's like when you see people say, I don't even like to say we've proven the consistency of language. We've demonstrated it, right? Because we'll get to it again. I'm still going to get to my paper eventually, but right, the context of how do you present a fundamental theory of language when it's naturally how language works and people are already operating on it, and you have to use language to introduce it. It's very, very kind of convoluted. But you just kind of have to say the right buzzwords to catch people's attentions for 30 seconds and hit them with a fundamental proof that they can't deny. Which, believe it or not, is a lot of work. But if words weren't consistent based off of our universal experiences and having the same reaction times, we wouldn't be able to converse. Like, none of the things I'm saying would be able to be intelligible to you. You would not understand them if there was no consistency to language. There'd be no natural pace and tempo to language. And so, like, it's just like the most basic thing, but if you just say that, no one would be like, oh, that's a fundamental proof. But that's the whole point, is it is fundamental, and it's true. It's empirically true. And so then I did a lot of just derivation again with sensorality. Just the linguistics is when I just go crazy. So I don't like to read through all of it, but I'll just do some of it. But we had a new fundamental theorem of mathematics that separation is the opposite, or separation is division. And so integrationality, again, just doing it in total generality, just putting the ality suffix on the end. But so then we have the opposite. Now we're gonna, again, we talked about we can modify the implications of the mathematical operators. Just what did the logic behind those operators produce? Because again, addition, subtraction, multiplication, division, exponentiation, and then we'll get to the interesting part. But like those have been axiomatized, like I said, since antiquity. And so how can you modify what addition means? Well, it's like, well, we're gonna do so. Here we go. And so I don't know if we'll do it right now, but like this is, I mean, you have to think to prove an axiom. You have to think through all of these implications. All right, so we have integration. What is integration? Integration is when you add something. You take one thing and you put it into another. I'm going to integrate a user interface into my app to make it more efficient. It's more, I have less clicks to get you to buy something. Just to use a business example, right? But let's consider the mathematical operators, right? We have addition, and people, I would say, what's the opposite of addition? Well, people will say subtraction. So what are those two things physically? What are we doing when we execute those operations? If I add something, I have one thing, 1 plus 1. I take one thing, I add something else to it, and now I have a set with two things, two objects, two elements. So I've integrated. To add is to integrate, right? If you're putting a new user interface into your app, you're adding it to your software. Sorry, I just took a massive bong rip. But, right, so how about subtraction, right? So how do we make that completely general? Subtract, subtractality, subtractivity. And so, right, if you subtract something, you take it away. And so if you take something away physically, you remove it. And so if you remove it physically, you censor it. So now we can relate sensorality to subtractivity, subtraction. To subtract something is to censor something. And so clear logical connection, clear linguistical connection, starting with the S, and now we just have to reduce the syllability and show its consistency. But what about exponentiality, right? Those are our three fundamental groupings: adding, subtracting. Adding goes to integrating, subtracting goes to division, but we've now encapsulated that into sensorality. But what is the opposite of exponentiality? If something grows exponentially, compound interest, the hype for a video game or for a stock or for the new iPhone or whatever, right? What is the opposite of exponential? Something getting faster, increasing acceleration. Not only is it getting faster, but the rate at which it's getting faster is getting faster. And so the opposite of exponentiation mathematically is, right, if you have an exponent and you want to do the opposite of that, you root it. R-O-O-T. But that's not really like a fundamental word. That's like a tree branch or root. But if you root something, you're getting to zero. You're getting to the bottom. You're undoing, you're reciprocating exponentiation. And so the word rooting is kind of the logical slang, right? When I'm saying like it's like you take a car and you strip it down to its nuts and bolts and you put it back together. You can see where people have missed things or where you can add things or whatever. But the word rooting is very not fundamentally ontological. And so, because right, we have a square root, but then you can also do an nth root just to any natural number. And so, but the word rooting, when you root, if you take an exponent of a number or of a set or of whatever, and then you want to undo exponentiation, then the logical opposite is rooting. And so we have adding and integrating, subtracting and censurating, and exponentiating and rooting as our 6 different operators. And so we'll move on, we'll do more with that when we can, but literally modifying the implications with proof of what mathematical operators do. Which is if you guys knew what mathematics was, that's the cool part. What's the difference between a base and basis? Again, we had to discuss that in the previous episode, just what's basis plural, how that can't be bases, it has to be basises. Don't know how to do that logically, but it's foundation. But what else can we say? Not sure. Did a lot of things with sensorality. We talked about the color codes. To equate some more things to physics, just again, always keep this grounded in real life things. What does something exist that we can say sensors with a C in our everyday life? A strainer. Strainers exist, right? If you make spaghetti and then you strain the water, STRAIN. Sensorality, that's an inanimate object. Strains. And so now we have, again, sensorality with a C to a direct physical object that everyone knows that starts with an S. So again, just buckling down, keep pushing these 2 different ideas, the same linguistical word, but logically separating them. To strain is to filter, sensorality strains. To strain is to pull. If you strain a muscle, you pull your muscle. Alright, so a muscle connected to stability, but right, then we can connect that logically to push or pull, like all forces are a push or a pull. So if you pull your muscle, you've strained it, so you've over-forced it or you've over-exerted it. A force is an exertion. But sensorality pulls, again, we discussed how sensorality is defined as attraction, both in emotionality, right? If you're an attractive person physically, or your personality, or just because you're really fat and you have a lot of mass, you're attractive, you're sensorial. And so sensorality pulls, attraction pulls. Sensorality now is obviously clearly rooted on sorality. And then so-reality, and then surreality. I'm not going to type these all out on the screen because, again, this is why I do way more of this listing of logic with just the words that I make it, but I'm just covering what I like. But like surreality, if you just put ality on the end of that, clearly everyone uses that word where it goes surreal feels like foreign. People, like if you look it up on Google, will say bizarre, but the real word they're looking for is foreign. It just feels abnormal, or again, foreign, doesn't feel natural, but in a good way. And if you say bizarre, it kind of has a negative connotation or an off-putting connotation. So we connected it to that. Reality. What is surreal? Just define that. But expectation creates pressure, right? You've heard the term peer pressure. But again, physically, expectation creates pressure. When you're thinking, when you're trying to learn something new, and you sit down there and study for hours and hours and hours, and your head feels kind of like thick or like full, that's expectation creating literally physical pressure. But trying to learn something new. So again, we talked about how if you set a rhythm, you move in time. You set an expectation of where the next pivot's going to be. Like if you're dancing, if you have rhythm, you're going to make a dance move on the beat in time. And so that's not for white people, so you got to watch out for that. But now we can connect, right, pressure, pressurality, generalizing pressure. linguistically. And then we have sure, and then surality, because that's the operative syllable. Pressurality, pressure. So sure, like S-U-R-E, like sure, okay. So now connecting it to basic English diction. And then surality, just sure, but generalized. And then you go, in an example, people will say sure, whatever that means. Again, we've talked about when people don't know what they mean, they default to talking about sexual analogies. You can prove that by saying that's what she said, or pause, or sexually at the end of something that doesn't make sense, and you'll get a chuckle from the other immature people in your group. Big fan of that. But you can also say sure, whatever that means, to some word jargon, word salad, and make your point. Let me pause there, see how long we've been going.